Okay, so let I be a root of x squared plus 1 equals to 0. That is I is the imaginary number. And omega be the root of x squared plus x plus 1 equals 0. Uh, and we need to construct fx equals integer valued polynomial. I mean a polynomial with integer coefficients. So that is, yeah, these are integers. Such that fi plus omega is 0. So we have to construct a polynomial with all integer coefficients such that iota plus omega is the root of that function. So many ways to solve it. Can you just find the coefficients quickly? Can anyone guess what's the minimum degree of such a polynomial from the root?
So is it 2?
No. So this angle is 90. This is 120. So this is 30. This angle is 15. So this whole angle is 105. This is just a pictorial representation. You can solve it fully algebraically if you want to. We know omega is cos 2 pi by 3, right? Cos 2 pi by 3 plus iota sine 2 pi by 3. So that is minus half plus iota root 3 by 2. And iota is just iota, right? 1 times iota. So we have omega plus iota equals half plus 1 plus root 3 by 2 iota. So if this is a root of uh, the equation. So let's call this alpha 1. Now alpha 1 is a complex number. As you can see, it has a non-zero imaginary part. So since the coefficients are all real numbers, here ai's are all integers, hence real. So there must be alpha 1 dash, which is also the root of this function, to make it real. So this is the conjugate of alpha 1. So this is also a root of fx. So let's multiply them together. So x plus half, this is minus 1 plus x plus half plus x squared plus 1 fourth plus x plus 1 plus 3 fourth plus 2 root 3. Oh, sorry, just root 3. That is x squared plus x plus 2 plus root 3. Right, so this thing, call it gx. So gx divides fx. Now, this is already already a polynomial of degree 2, but we are still not done. They are not all integers, right? So we have to square it once more. So now instead of complex conjugates, we have uh, irrational numbers. So now we have to find another set of conjugates. Therefore, fx has to be x squared plus x plus 2 minus root 3 times x squared plus x plus 2 plus root 3. Expanding, we get x squared plus 4 plus 2x cubed, 4x squared, 4x minus 3. Sorry, should be minus. So that is like the minimum possible polynomial for x for fx such that iota plus omega is a root of f. And as you can see, all the coefficients are integers also. So it's nzx. Right, so any doubts? Pretty straightforward. So the next one.
Sir, double root meaning?
Repeated roots, that is, the factor containing that root has to be more than one, that is double, so it's squared. So second problem is, so we have a polynomial x plus 2 squared times x plus 7 squared plus a equals 0. X is a real number, so this is a constant, unknown constant. Okay, so we have to find all values of a such that this equation, so let's call this equation 1. So find all values of a such that equation 1 has exactly one double root. Okay, so like if fx equals to x minus b whole squared into x minus c whole cube into x minus d whole power 4 into x minus e, then we say e is a single root, like nothing double or triple in it. But b here is a double root, c here is a triple root, d here is a like a root of power 4. So we say so fx is said to have uh, a root e of order k if and only if f and the k minus 1 is derivative of x. So this is a equals to 0 and if ka not equals to 0. So if the k derivative of a like a is not a root of the polynomial which we get after k times differentiating f, but with one less differentiation a is still the root. So you get the idea. It's basically like how many factors we have of x minus a in that function. Okay, so yeah, so find the value of a. I will mute myself for 5 minutes. Okay, so anyone guess the value of a? Yeah.
So we can factorize that thing into like yeah. So I mean a square minus b square form, like x plus 2 whole square into x plus 7 whole square plus root over minus a into x, that into minus root over minus a. Then we can convert one of them into perfect squares.
You mean like this?
Yeah, sir. Then we can convert one of them into perfect squares.
Uh, like, okay. But it's not a perfect square of some integer, or this is not a question of number theory. So why are you trying to make perfect squares here? Like, we have to find the values of a. It might not be even unique. So,
So if one of them is converted into perfect square, then we have got a double root.
okay, let's try it. So how do you wish to solve? Like, how do you wish to proceed now?
Sir, I proceeded with the discriminant method.
So you are treating it as a quadratic in x. Okay, so
Yeah, sir.
d is 81 minus 4 times this thing.
Sir, that's root d, I guess.
That which one? Oh, oh, okay,
And sir,
okay, okay.
it isn't. Sir, by the way, it isn't k square. It should be zero because we are given the function to be zero. Like, I mean, sir. Yeah, sir. It should be not f of right hand side. Shouldn't be f of x or something like that. It should be zero. You have assumed, sir. Sir, you have assumed. Yeah, yeah, sir. No, it's correct. K square shouldn't be there, sir.
No, like I'm not substituting. Just a minute. This was the equation. If wait, like
K
if we
square should.
substitute k to be zero, like here,
Yeah, sir.
then what's the use of, like, how are we imposing that double root condition anyway?
So, what to say? For a perfect square, like for a, I mean, for a double root, the quadratic equations discriminant should be zero, right? So we are trying to find that only.
Okay, let's see how much this gives. So this has to be zero. So
Yeah,
then
sir.
81 by 4 equals 14 minus iota a. So iota a is 81 by, sorry, 14 minus 81 by 4 by iota whole squared. So it's negative of, doesn't matter. How much is that? 31 minus 6, 25.
21, 25.
So it's minus 5 by 2 power 4, right? Okay, okay, yeah. So you are getting the correct answer. That's nice. I never thought of this approach. Okay, so here we are putting discriminant equals to 0 since we want repeated roots. This is actually even pretty neat, and is probably a bit more generalized than what I did. So I just so this part, let us call it some gx, and first I did wavy curve on that. So we have got gx equals x plus 2 squared plus x plus 7 squared. So we have minus 7 and minus 2 as the critical points. Plus minus plus, sorry, plus plus plus, since they are positive power. So we can roughly guess the curve has to be something of this sort since it's continuous at all the points on the real line. So now there is a maxima here somewhere between minus 7 and minus 2. So let's differentiate it to find it. So this is a cubic equation, of course, since there are 3 points of, what do you say, 3 critical points. So we already know that minus 2 and minus 7 are one of those. So we can cancel out one factor of x plus 2 and one factor of x plus 7. So then we are left with so we're just trying to find this value of x. So 4x equals minus 18. So it's equals minus 9 by 2. 9 by 4. Sorry. What am I doing? Yeah, so 9 by 2. So, so now we know like this thing looks like this is minus 9 by 2, this is minus 2, and this is minus 7. Suppose this height is something h, and now our fx is of the form gx plus a, right? So, so any root of f, so let lambda be a root of f. So f lambda is 0. This implies g lambda is minus a. So basically we have to shift this graph g downwards uh, by some value a, such that the it cuts the graph g either at 1 2 1 2 3 4 points, or 1 2 3 points, or 1 2 points, or yeah, 2 points is pretty common. Like here also, if we cut it, it will have 2 points. But what do we need? We need exactly one repeated root, right? So if we observe that if we cut it here in the first case at exactly the way it's like if we substitute a equals to 0, then it touches the x-axis at minus 7 minus 2. There we get two repeated roots, like both -2 and -7 are repeated. Then if instead we consider this line, this is somewhere a somewhere between 0 and h is this height. So then we get all four distinct roots, right? So we get all four distinct roots. This is a root, this is a root, this is a root, this is a root. Lastly, if we pick this line, then it exactly meets our expectation or our requirements. That is, we have one repeated root and two non-repeating roots. And here also we don't get that. So of course we have to, there's only one line, which is a equals to minus h. So let's calculate h. So h is g of minus 9 by 2. That is, so it's anyway squared. So h is 5 by 2 whole power 4, and so we got a equals to minus h equals to minus 5 by 2 whole power 4. So this is a more, what can I say, exploratory way of doing things. But yeah, but this method was indeed pretty general, and like you might stumble upon this one without having to like play around, right? So this is a better method. Okay, thanks for this one. So now the third one. This is a pretty famous problem. So we have points A and B on x and y axis respectively. So B is on y axis and A is on x axis. The line segment AB has a midpoint C, and okay, so the AB is on the first quadrant and it has a fixed length of 2D. So this is 2D. This is a perpendicular dropped from point P to C such that this length is also D. Okay, so now we have to find the locus of point P. So find the locus of P. C is the midpoint. Quickly calculate it. This is also easy. I'm sure you must have done it also. Like it has many variants. A cat moving down, sliding down a ladder, and even a pigeon which is like following the cat. And I guess this is the pigeon version. Okay, so try it for 5 minutes. Okay, so what is the locus coming? So let P be at some point HK. Now we will assign this
So the
node.
locus is also a straight line.
Yes, but
So
it's
it's
not a,
coming as B. Sorry, no, 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 Kishun. I assume some values that should be removed. I didn't actually. Sorry.
okay. So if you assume this is theta, then this is like 2d sine theta. I'm sorry, this is cos theta, and this is 2d sine theta. So b is 0 comma 2d sine theta, and a is 2d cos theta comma 0. So the midpoint is, so c is d cos theta d sine theta. So now we got c. We need to find p, right? So what is the vector along? Like we have to find the normal vector of this line. So what is the vector along this line? So the vector along this line is positional vector. This is O. So positional vector of B minus positional vector of A. This is AB. So this is positional vector of B, as we found, is 0 sine theta. It's only we need the normal vector. We can let go of the 2D. Then cos theta and 0. So minus cos theta sine theta. That is also a unit vector. So the unit vector along AB is this one. Therefore, the unit vector perpendicular to AB is, so we, yeah, so you just swap them, sine theta minus cos theta, and you just remove the, just flip the sign of the right coordinate, so make it plus as it was minus before. Right, so you're basically multiplying with minus iota here. So what is the corresponding complex number? So corresponding complex number is minus cos theta plus iota sine theta. So multiply that by iota, minus iota, sorry. So we get cos theta minus minus iota squared. Iota squared is minus 1, so we get plus sine theta. So that is equivalent to sine theta cos theta. So here we get sine theta cos theta. So that is the normal vector along this direction. Okay, so the distance is d. So the positional vector of P, this is
Sir,
equal.
ain't AB AB should be written as OB vector shouldn't be written as 0 comma d sine theta.
Yeah, this is actually I'm writing the unit vector just for convenience.
Okay,
Sorry.
okay, sir. I was just like I just wanted to confirm whether which is right.
Yeah, it is 2d sine theta actually. Yeah. So P vector is so this is OC. So P vector is OP vector is OC vector plus CP vector. OC vector is, we can write one more step. This is times d, sorry, cp cap times d. OC vector is d times cos theta sine theta plus d times cp vector is cp vector is same as AB ortho, right? So it's sine theta cos theta. So we have d times sine theta plus cos theta, sine theta plus cos theta. Okay, so that is our P. Now we just have to eliminate things. So it's of course like it's uh, obvious that both the coordinates are same. So we don't there's nothing to eliminate. So h equals to k equals to d sine theta plus cos theta. Okay, so we just got the line x equals to y. But this is not all. We have to find the range of h and k. So so theta is in the range. Looking at the problem, since it has to be in the first quadrant. So one extremal position is this one, where theta is almost pi by 2. The other one is this one, where it's almost 0. So it's open intervals uh, pi by, sorry, 0 to pi by 2. Therefore, d sine theta plus cos theta. So at 0 it is 1, and at pi by 2 is also it's 1. So no, like we have to find the range. So let's differentiate it. So let f theta equals d sine theta plus cos theta. So dash theta is cos theta minus sine theta. So if dash theta is 0 at the extremal point, so cos theta is equals to sine theta at that point. So theta must be pi by 4 in this interval. Therefore, maximum value uh, of h, so h and k is less than or equals to d times 2 by root 2, that is root 2. And the minimum value is obviously 1. So from 2 and 3 we have, you need to find the locus of P, right? So the locus of P is um, x equals to y, such that x is inside d2 d root 2. Cool. So this was also a very easy problem.
We can also prove that the coordinates of P are equal by dropping the perpendicular simply, right? I mean, it is more easy.
By taking the
I mean, we can see that PA is equal to PB, right? And then we can make a rectangle. Uh, yeah, PA is equal to PB. Drop a perpendicular from P to x-axis and y-axis, and then see both the triangles are congruent. So x is equal to y. and hence then we can find that after getting this we can find the bounding on x, that coordinate of.
Okay, so these two are congruent, right? So let this be b dash and a dash. So this is theta. This is mm, so this is a squared,
Yeah,
right? Yeah. Since this is 90, this has to be 90. Okay, so this is a square, so obviously this thing has to be the, like what you say, the median of any triangle. And since it's isosceles too, so yeah, like those two triangles are congruent, so we have x equals to y line. So this is x equals to y. Yeah, that was the most straightforward way. Actually, all these variants of this ladder problem, I had practiced them with these kinds of vector methods, so I just straight away ran for one, not thinking simply. Okay, so you see, you can easily score like how much? I forgot how much was the marking for each. I guess it was 7 marks, right? So
10
it was 10,
for
right?
this.
Oh, okay, I forgot.
10 into 8.
Yeah, so you got 30 marks. I guess 35 marks should be enough to qualify. Oh, we need to solve one more. Okay, so
No, I think in 2020 cutoff was high because paper was very.
Yeah, sir. In some years the cutoff,
so
like
they don't
they
they,
solve
they
five
don't
questions
disclose the
complete
cutoff.
then also. Yeah, sir.
I
They
don't know.
have
I actually then performed pretty badly. Still, I
Sir,
don't know.
last year I guess it was 30. They disclosed it later.
Okay, I don't know. Okay, sorry for that. It was 30, so it must be difficult, that paper. I haven't seen it yet. So
is there any cutoff for subjective also? I mean,
yeah,
I don't
like
think so.
they just use the objective paper for an excuse to whether or not to check your subjective one.
Yeah, I know that, but I mean, you're saying they don't disclose the cutoff, but they do, right? They say that UGA cutoff is this, and then overall cutoff, weighted cutoff is this, right? So that is only the cutoff. I
Okay,
mean, in
so
every result.
okay. Mm-hmm. And they do disclose a number. Right. So do they include the objective marks also in that?
Yeah, in weighted cutoff is.
Yeah, I remember they disclose like a cutoff for the objective paper.
Yeah,
Uh,
first they separately disclose the cutoff for the objective paper, and then overall weighted, like UGA plus 3 into UGB is somewhat. I think in 2020 it was 360. I don't know.
and what was the total marks of UGA in 2020?
120 and 80 into 3. Okay, overall it is. Okay, sorry. Don't-
Yes, it was, yeah, pretty lot of marks. So yeah, the subjective was even easier than the objective paper, I would say, except the last one, except the last one. So number four, I guess. Right. Uh, okay, this is a little difficult. So we have a real valued function. Sorry, a sequence in R. such that given limit n tends to infinity, nxn is 0. We need to find all values of t such that n tends to infinity xn, that same sequence, ln n power t is 0. So here, of course, we get intuition of how to solve it or how to go about it. Like xn obviously is at least the order of more than, like less than n power minus 1, right? So it has to be something like n squared or n cube or something. Then only this thing can go to 0. Now if it's any of those, like, uh, then ln n can never even reach the the decaying rate of n, let alone n squared or n cubed. So of course this has to be 0 for all values of t. So that's what you have to show by finding an upper bound for ln n power t by n for all values of t. So try to find an upper bound for this one. Should I wait for 5 minutes? Okay, so 2 minutes. I will wait for 2 minutes. So 2 minutes are over. Anyone found any upper bound for this bad guy here? So let's call it some uh, what do I wish to call it? GT. So t is a variable here. Or just a minute. Is it t really? No, sorry. It's n. So the variable here is n. So we have to find. So let's analyze gn. So what's g dash 10? So g dash 10 is n squared times t times ln n power t minus 1 minus ln n power t, which is ln n by n squared times power n minus 1 times t minus ln n. So, so now using wavy curve method or anything, you can obviously check that ln n is the critical point, right of which the function g dashed n is positive and left of which it's negative. Right. Okay, so and it does have a asymptotic point at n equals to 0, but we don't care since it will anyway go down. So for oh yeah, sorry, I'm missing something. Yeah, I'm confusing between the variables. So t is not the variable here. X is n is the variable. So this is not t minus ln n is. So I have to take the negative sign out. So ln n minus t. Now we can write it as, so we can assume log n to be x here. So we have the critical point. So when is this 0? When ln n is equals to t, that is n equals to e power t. Okay. So the critical point is e power t, the right of which it is negative and the left of which it is positive. Right. So we have, so g dashed n is positive in, we don't need to go as far as minus infinity since log is not even defined there. So, and 0 to 1, 0 to 1, is anything mentioned about it? About the domain here? Yeah, n is greater than or equals to 1. Okay, cool. N is a natural number, so n is of course greater than or equals to 1. So in n to e power t, g dashed n is positive and g dashed n is negative in e power t to infinity. Right, and g dash n is 0 at exactly x n equals to e power t. So it basically looks like increasing, decreasing. So we're getting a local maxima, which is also the global maxima of this function gx. Right, since g dash is positive implies gx is increasing, and g dash is negative implies gx is decreasing. So g e power t is a global maxima or upper bound. So we found our upper bound that we wanted for power ln n power t by n. So now the rest of it is just a bit of inequality. So we need to show, so enough to show, what do we need to show? We need to show, so limit n tends to infinity, xn ln n power t equals to 0 if and only if limit n tends to infinity n times xn by ln n power t by n goes to 0. We already know this thing goes to 0, and we have found an upper bound for this one. So so fix epsilon positive By definition, there exists a natural number n such that for all delta greater than 0, no, sorry, we don't need delta yet for continuity. So for all n greater than capital N, the distance between nxn and 0 is less than epsilon. Okay, so not epsilon, we have to, so it is, let's call this thing n. Okay, so g of e power t, so what is n? What is g? G is ln power t by n. So e power t, so it is t power t by e power t. Okay, so mt, since t is a parameter here, so mt is t power t by e power t. So mt. Right, so we get the corresponding n such that, I'll call it n1 then. Right, so we get the corresponding n1 such that this happens. Now, mod of x nxn ln n by n minus 0 is less than nxn ln n by n. It's actually equal to whatever. This thing is less than epsilon by mt, and this thing is bounded above by mt since we just proved that. So the whole thing is bounded by epsilon. Therefore, limit n tends to infinity xn ln n power t goes to 0. And this is true for all t, I guess. No restrictions on t, right? Just a minute. Yeah, so here, so e power t is well defined for all values of t. And anyways, we only have to show it for, yeah, so for all for all real values of t. So all real values of t, right? So that proves our claim of, like, it is true for all values of t. So does that make sense, right? Any doubts?
Sir, actually, sir, could you please just give a brief explanation of the solution again? I actually got disconnected in the middle.
Okay, so our idea is to like xn. So can you guess a sequence xn such that this happens at first condition, that nxn is 0? Obviously xn has to have a factor of n squared, or
1 by n squared or higher
yeah,
than n,
yeah,
degree
higher than
higher
n,
than n.
right? Right, and if suppose n squared, so in the second equation, if you substitute that, it's n squared times log n power some positive, like any power, okay, right? So we know that logarithm is way smaller than linear rate, right? So we just need to show that it how much large can t be, but still log n can never surpass the decay rate of n, even if let alone surpassing the decay rates of n squared. So to do that, we need to find an upper bound for this quantity, log n by n. Since then, we can use xn times n times ln n by n, not the whole power. Yeah, so then we can say that this factor already goes to 0. And if we can bound this factor by some m as a function of t, you can say, since t is
So
constant.
what if ln to the ln n to the power t surpasses n square some value
No,
or the other
yeah,
it
yeah.
will now.
That's what we need to show. We need to prove that ln n power ty n never surpasses one. No, not one. Never. Like this is finite. Ln n power ty n is finite. We need to show that it is bounded above by something, by some constant, non finite constant. So for that we take gn to be that function ln n power t by n. Actually, it is gt of n. And then we differentiate it. We get so we get the critical point as e power t, since ln n minus t is 0 at e power t. On to the right of e power t, since the function is negative, so g dash is negative on the right. So this is gx. So this is the graph of gx. If we draw the graph of g dash, it's something like this, e power t. So corresponding this gx graph will be decreasing on the right of e power t and increasing on the right of on the left of e power t. So so e power t is a global maxima uh, in the range 1 to infinity, for n in the range 1 to infinity. So so our gx is always bounded above by this quantity, e g of e power t, not gx, gn, right? So we call that quantity mt. Now we just use the fact that nxn is converging and it converges to 0. So we got a corresponding n1 such that this thing is less than epsilon by mt. And then we can just um, like put up the framework for proving the limit xn times ln x power t multiply and divide by n, and this is bounded above by mt, and we took epsilon in the first case as epsilon by mt. So mt gets cancelled out, we get epsilon. So we were able to prove that for all n1, there exists n1 for all epsilon, such that for all n greater than n1, uh, mod of nxn is less than epsilon. Sorry, mod of xn times ln n is less than epsilon. So that is, in other words, the limit is 0. Right, is that clear?
So we assume xn to be 1 by n square or something like that. Then how
No,
come 1 by n is coming?
we don't assume anything. That was just our intuition. That was just our intuition. We just find an upper bound for this thing so that we can use it here to bound this ln n by n by mt.
So that I got, but how did you find that? I didn't like. Just show me.
Upper bound of ln n power t by n. Yeah, that I found
Yeah,
using normal calculus, like analysis of that function. So we assume gn to be that function of n, ln n power t by n. So we got g dashed n to be minus of ln n power t minus 1 by n squared times ln n minus t. So that gives e power t as a critical point with positive on the left hand side and negative on the right hand side. That makes e power t a global maxima. So in other words, we can bound gx by anything more than g of e power t. Is it clear now?
yeah, sir. Somewhat I would like later analyze.
Okay, okay. Okay, so we're still left with problem three problems. Okay, quickly move on to problem five. Oh, fortunately, we have solved this one, I guess, last class, or it was the same problem, right? Like the largest pentagon in terms of area that can be inscribed on a circle of radius 1 has to be regular. So we have to inscribe a pentagon inside a circle and show that the largest one has to be the one with equal sides. And well, it's like there are a lot of ways to do it. I guess I won't go through the proof once again since we discussed it last week in 2009 or something. It's a common problem. So the sixth one. This is also a pretty routine problem. So we are given a differential equation. Oh, sorry, we are not given the differential equation. We need to find the differential equation by eliminating the arbitrary constants. So this is the curve, or to say the family of curves. Oh, so we are also given the differential equation. The differential equation is y dashed a squared minus b squared x plus y. So we need to prove this equation fits this differential equation. Of course, lambda is the only arbitrary constant, so this equation has to be first order, which it just a minute, just yeah, this is the first order differential equation, right? Yeah, it's just not linear. Okay. So to proceed, so let's differentiate it with respect to x. So we get 2x, 2y. Cancelling out 2, we get xy squared plus lambda equals to minus y dashed by b squared plus lambda. It is xy minus y dashed equals to a squared plus lambda by b squared plus lambda. So we need to get a squared minus b squared somehow. So let's apply componendo dividendo. So a squared plus lambda minus b squared plus lambda by b squared plus lambda x minus y dashed by minus y dashed. So this is componendo dividendo. Next we need to eliminate the lambda in the denominator. Hmm. For that, for that, just a minute. Okay, we can use the original equation once more. So from 1, call this 2. So this is 1. We have 1 minus x squared by a squared plus lambda squared. No, not lambda squared, just lambda equals y squared by b squared plus lambda. So here bring down y squared. That's not eliminating lambda. So from here, let's let's do the other way around too. So minus y dashed by x is b squared plus lambda by a squared plus lambda. X minus y dashed by x is a squared minus b squared by a squared plus lambda. Cool. Now we can divide 3 by 2. So 3 by 2 or it's better to divide 2 by 3. since I want to keep b in the bottom. So b squared plus lambda a squared plus lambda x minus y dashed okay, what am I doing? So got back xy minus y dashed. So
Sir, finally,
okay,
I have arrived to a conclusion where a square plus lambda equals to 1.
e squared plus lambda equals to 1.
It's really funny, sir.
Okay, so what do we have on the right hand side? X plus y dashed, x plus y dashed, and xy dashed minus y. So why not multiply those two? So x plus y dashed. So x plus y dashed by x is a squared plus b squared plus 2
So why
lambda.
not we use simple substitution?
Yeah, we can, but it will be a bit messy, and I will. Like, you can always do that, but
So that's what I was doing. Hence the conclusion: a square plus lambda equals to 1.
okay. Let me check once. Just a minute. Uh, how will I get? Oh, okay. So we can divide by y dash. Set. Minus b squared plus lambda by y. So we know x by y dashed is a squared plus lambda by b squared plus lambda, and we need to find x plus y dashed. X plus y dashed. Okay, we can take common x instead. So then it is okay. Here I messed around a bit. And I wrote so here when I did numerator minus denominator, I gave a minus sign here, but that should be plus since the denominator was already negative. Sorry. So, so this is plus. So what are we left with now? A square minus b square. Let's keep it on the right left hand side along with 1 y dashed. The right hand side we got x plus y dashed times b squared plus lambda times a minus y. Okay. No, sorry. Y is in the denominator. So minus y. Okay. Now we can substitute uh, y by b squared plus lambda. So we can multiply and divide by y. So now we have got 1 y squared by b squared plus lambda. So y squared by b squared plus lambda is 1 minus x squared by a squared plus lambda. Right. Or since we anyway need a differential equation, So what do we need out here? X y dashed minus y. X y dashed minus y. Now we can substitute like, sorry, 1 minus x squared by a squared plus lambda. How is that helpful? Xy dashed minus y. This has to be equal to b squared plus lambda by minus y. So this is equal to x by y times y dy y dashed minus y. Okay. So b squared plus lambda by minus y. We multiply it by 1, and 1 is like x squared by a squared plus lambda plus y squared by b squared plus lambda. That gives us x plus y dashed times 1 by y dashed times x squared b squared plus lambda plus by a squared plus lambda. Uh, okay, let me multiply out the y also, the denominator. So we get y, just y. Okay. Now we know b squared plus lambda y squared plus lambda is y minus y dashed by x. So we have minus 1 times, so minus y dashed by x times x squared plus y, right? Is multiplied. So what is this? So if we take minus y common, we have xy dashed minus xy dashed plus 1, 1, right? Yeah. So this is 1 minus xy dashed. What do you need to show? So now we are getting a y extra. That's strange. Oh, okay, okay. So when uh, so there was a y here, and I put it back inside. So here should have been a 1y. So that y should have cancelled with this one, and we don't need to pull out a y anymore now. So minus x y dashed plus y. So taking this minus 1 inside, we have y minus xy dashed minus y times x plus y dashed equals y dashed times a squared minus b squared. Cool. So that proves the differential equation. So multiplying it with 1 was the most trickiest part, I guess. But so you can do it in a lot other ways. Okay, so just two problems are left. Let me try the seventh one. So we have a right angle triangle with integer sides. So ABC, A is strictly less than B, strictly less than C, and they are also pairwise co-prime. So GCD of A and B is GCD of B and C is GCD of A and C is equals to 1. D is defined to be C minus B, and suppose D divides A. Okay, so D also divides A. So all these things are given. So we need to show that D is less than or equals to 2, and the second one is find all such triangle. So A plus D plus C is less than 100. So find all triangles. Find all possible tuples. So here, to prove the first part, so how do we show something is less than something? Here, obviously, it's a problem on number theory and Pythagorean tuples. So our primary aim will be to prove d divides 2 divides d somehow. Then d has to be less than or equals to 2. So let's try that. So how to do that? So d divides a, d is c minus b. So c minus b divides a. We also have a squared plus b squared equals to c squared from Pythagoras. So c squared minus b squared is a squared. So c minus b into c plus b is a squared. And c minus b already divides a. So this is d. D divides a. Now, uh, so so d squared divides a. Right. This implies d squared divides a. This implies d squared divides c minus b times c plus b. So that implies d divides c plus b since like since c minus b is already d, right? So c plus b is also divisible by d. Therefore, d divides the difference. So therefore d divides twice c. Now since d and c have a GCD of 1, this implies d divides 2. So d is less than or equals to 2. So that is the proof of the first part. For the second one, find all triangles. Okay. So a plus b plus c is 100. C minus b is less than or equals to 2. Now, now c is obviously greater than b, right? Since c is the hypotenuse. So c can't be equals to b. So c can be either equals to b plus 1 or c equals to b plus 2. Let's check the first case first. So we have a plus b plus, sorry, okay, b plus b plus 1 equals to 100. And we also need to have a squared plus b plus 1 whole squared, sorry, not b plus 1, a squared b squared equals to b plus 1 whole squared. So squared minus 1 is 2b. That gives a plus b squared minus 1 is 99. So we got a quadratic. So is
So in the previous one, I got d square should be less than equals to 1. That means, like, obviously it should be less than 2.
wait, how did you get that? I don't think that's
So okay, so I like, what to say? D is equal to root over a square plus b square minus b. Right, sir? No, no, b, that last root over a square plus, sorry, whole root over a square plus b square. Then after that, minus b. Like, out there, minus b is outside the root.
how did
So,
you get that? Just a minute. So this is basically c squared. So you say okay, yeah. So next,
then d, since d divides a, therefore we can assume dk is equal to a.
yeah. So that implies a equals to kd.
Yeah, yeah. And sir, from the previous, what we assume, like, oh, that one, the root over a square plus b square minus b. I'm sorry, I'm saying it now. A is equal to root over b square plus 2bd. Then I started to solve, and the
B
quadratic came.
squared plus 2kd.
2 bd d squared plus 2bd. Then I substituted the value of a. Then a quadratic equation came.
A squared is and this is d times c plus b. Uh, d square plus 2bd. Okay, let me just directly substitute c minus b. So 2bc minus 2b squared, 2bc minus b squared. No, it's not coming as a, right? Why is this a? Why square root of b squared plus 2bd is a? Is it what you are claiming, that a is equals to b squared plus 2bd? Right. Excuse me.
Oh, no, no, sorry.
Okay, so
I
it's not
committed
right.
a mistake. No, sir, it's not right. Sorry, I committed a mistake.
Yeah, okay, so that happens. Right. So you don't have any issues with the first proof, right? I just showed d divides 2, so d has to be smaller than 2.
Yeah, sir. Yeah.
So now we got a equals minus 1 plus minus square root of b squared 4ac. Why am I getting such bad numbers? So oh just a minute. There was an inequality. Yeah, that was less than 100. Sorry. This is less than or equals to 100. Yeah, no, sorry. It's actually strictly less than that. Okay. So we have the discriminant less than 0. This implies minus 1 plus minus square root of 400 is uh, how is that helping? Okay, so when a squared is equals to 2b plus 1, so a squared is odd. So that implies a is odd. So a does 2 doesn't divide a squared, 2 doesn't divide a, implies a equals to 2k plus 1, right? So if a is 2k plus 1, we have the whole perimeter as a plus a squared minus 1. This is the perimeter. So it is 2k plus 1 squared, 2k plus 1 minus 1.
By the roots of the quadratic, can we say that a for the roots it's between minus sorry 1 minus root over 401 by 2 and 1 plus root over 401 by 2. That means the a should be between minus 10 to 10, right? In that case, a should be less than 10.
Just a minute. Uh, yeah, so
I mean 9. It's root over. It's near about root over. It's about 19 by 2. So 9.5 by less than 9 or equal to 9.
it
And
is
on
minus
the left hand side, it's like
t. So
minus 10.
it is equals to 100 minus t. So we have a squared plus a minus minus t minus 100. It's plus, no, sorry, 100 minus t, right? It's 100 minus t. We can just make it plus t minus 100. So then we got a quadratic as so 401 minus 4t. So a is this quantity, and now we can uh, toggle the values of t from something like 100 to how much can we make it? We can't make it negative, so to 0. So e is obviously less than minus 1 plus 401 by 2 and greater than minus 1 plus Can it? What did you say? What is the range of a? Can it be? It can't be zero. What is the next value? Four. It can't be four also.
So
Just
the
need a.
root is one of the root is it's near about -10. So definitely it can't be zero or any negative. So we can start from one or yeah one.
Uh, we are given these are integers, right?
So
I
that's
hope
why
so. Yeah.
then the minimum is one.
So a is between 1 to 10. Yeah, pretty good bound, I guess. So this is the
So better
case
to
where.
write nine. So better to write nine instead of 10. So cause 20, it's root over 20 more or less. I mean root over 401 is near about 20.
Yeah, and can it reach exactly 1? I doubt it can. Okay, so now we can just case batch things. So number of odd numbers between 1 and 9 is 1, 3, 5, 7, and 9. So as we know already that a is an odd number. So if a is 1, then we get 2a plus, what was that? So a squared minus 1 by 2 is b. So b is a squared minus 1 by 2. So b is
It is
can't be 0.
zero.
Yes,
No.
this can't happen. So if a is 3, then b is 8 by 2, that is 4. And c is,
Five. Obviously, sir.
yeah,
Five.
yeah. So it is b plus 1 case, so 5. So 3, 4, 5. I don't think we need to recheck that Pythagoras condition. It should be already true. So 5. We get 24 by 2, that is 12. C is 13. That is another tuple. So 5, 12, 13. I hope I'm not. Okay, GCD 1,
Yeah,
yes.
sir. It's correct.
Now 7, 7, 49 for 24. C is 25. That is also tuple. Lastly, with 9, we have 40 and 41. Yeah, they are co-prime also, I guess. 40, 41. Hope they are Pythagorean tuples. So should I check, right? So 81, 40 squared is 1600.
Yeah, sir. It's done.
41 is,
So 41 square minus 40 square will also work.
yeah. So we already got, four tuples. Four tuples from the first case, b equals to c minus 1. So case 2, c equals to b plus 2. Similarly, we can like a plus b plus 2 is less than 100. And from there we have a squared plus b squared equals b squared plus 4b plus 4. So a squared minus 4 by 2 is 2b. Right. So here we get, sorry, why have I didn't see? A plus 2b is a squared minus 4 by 2 plus 2. So we're getting a plus less than 200. So basically, we can do another similar 200 plus t. I guess the bound is coming as 20 or something, is it? So it is 804. So 804, the square root of 804. 10,000 should be, sorry, 1,000 should be 300, 330, I mean. Right, so less than 30. Should be 29, I guess. 29. Let's go for 29.
So we must assume the minimum, right, instead of the maximum.
Yeah, so
We should go for 28 instead of 29 because it comes like 2.280 in like 28 point something. I think so.
but according to my calculation, should be greater
So
than
root
800.
over 804, we can approximate it to 800 because it's such a large number. So 800 is 400 into
Okay,
2.
okay.
So 20 root 2.
Yeah, we should go for 28. So this is 26, so 13. Should I assume equality or shouldn't I? By the way, A should be even in this case, I guess. Then okay, so it doesn't matter. So what is A? So A squared minus 4 is 4B.
A is something divided by
4
divisible
4
by 4,
divides
right?
A
So
squared. So 2
hold on.
divides A. Yeah, so A is even. But still, the number of even numbers. Just a minute. So 4 divides A squared, right? Mm,
Yeah, then 2 divides A. But 2 isn't possible in this case. So let's start from 4.
I guess we will be able to show 4 divides this somehow. Just a minute. Let me check the other conditions. So 4 divides A. 4 divides A squared. Nothing more. Maybe we have to check all those 6 even numbers. But I think I had showed somehow that 4 divides A, so brought down the list by. Oh, by the way, I am running out of. I think I have crossed my time way back. So okay, so let's.
Yeah, sir. We both are only there. No one is there.
Okay, so I didn't notice actually. So let's quickly find. So let's check for L equals to 2.
Not possible.
Yeah, so yeah, so it is 0. So not possible. A equals to 4. 16 minus 4 is 12. 12 by 2 is
3. Yeah,
3.
yeah, 12 by 2, 6.
6 and 4 is 3. Yeah. So B is 3. So
So
B
C
is
is 10.
C
So
is
C is
10.
10.
Not possible. Since just a minute, just a minute. So A and C has to be 1. What is A? Yeah, what is no, what is C? C is B plus 2. And A is A squared minus 4 by 4. Right. Plus 2.
So this case is itself not possible, I guess, cause uh, yeah, sir, sir, a square is always divisible by 4. 4 into k minus 4 is equal to 4k minus 4 by 2 is equal to 2p, right, sir? So then the GCD automatically becomes 2 minimum.
So A is of the form 2k, right? So 2k, 4k minus 4 by 4 plus 2.
So is it
So it
4 or
is
2? Is it 4 or 4k minus a square minus 4 by 4 or 2?
no,
If
it's
it's 2,
4
then
since this is
oh yeah, yeah, yeah. Oh, sorry, sorry. Because if
it's
it
a
was 2,
squared.
then the case
Yeah.
would be dismissed.
Then multiply by k and subtract once. So it's 1 minus k squared 2k. We can make it k squared minus 1. So yeah, so k squared minus 1 has to be odd somehow. So k squared minus 1, 2 doesn't divide, so 2 divides k squared. So that implies 2 divides k. Yeah, that's what shows A is of the form 4k. A 4k, I mean, change it to 4r. Yeah, that's why I said I had proved it as A 4 divides A. So that gives 4 divides A. So now we just need to check for 4, 8, and 12. So 4 is crossed since A and C are GCD is incoming 1. For equals to 2, equals to 8, we have b equals to 64 minus 4, 60 by 4, that is 12. No, just a minute. 60 by 4 is 15. Yeah, 15. And plus 2 is 17. This case works, right? For equals to 12, we have uh, 144,
32 into 2.
140.
32 into 2, 64 is equal to 8 square. Yeah, sir, this works.
So we have uh, 140 by 4, 36, 35, right? 35. C is 38. Sorry, what am I doing? 37. 37. This should also work.
Yeah, 72 into 2 is 144. That means, yeah, 12 square.
Yeah, so we got the tuples 3, 4, 5, 5, 12, 13, and 7, 24, 25 from the last case, and from this case only 2. Okay, so that's it for today. I will discuss the eighth one next week. Okay. Good night.
Good night, sir.